Notes for increasing sequences. In this next unit, we will be studying sequences of numbers, both sequences that are increasing and decreasing. In our first example here, you see we have a sequence. The first number is 4, followed by a 7, followed by a 10. The ... means that this sequence continues forever. Our goal will be to find the next term in the sequence, the 0 term in the sequence, which means the sequence before the first term. We will fill in the table. We will write an equation for the sequence in a specific form, and then we will pick a term and prove that the sequence equation is correct. As you can see, this sequence is increasing by adding 3 between each term. So to find the next term in this sequence, I would simply add 3 to 10, giving me 13. I'm going to write that in the table after the term with 10. To find the 0 term, we need to move backwards from the first term to find the term before it. Since we are adding 3 to the sequence, we will actually subtract 3 from 4 to get the 0 term. And you can now check the pattern in the table. From the first term to the second, we're adding 3, adding 3, adding 3, adding 3. So the pattern is adding 3. To write the equation for the sequence, we will start the equation with the term t with an n in parentheses. Okay? This represents the term number in the sequence. We will set this equal to an equation which would give us any term in the sequence if we provide the term number. This is very similar to writing an equation in mx plus b form. M is the slope in this equation. In this equation, it's going to be the change between terms. The y-intercept from this equation will be the 0 term in our sequence. So my equation will become, instead of y, we're going to write t of n, with the n in parentheses, equal to the change, 3, times n, the term number, plus the 0 term. So the 3 came from the fact that the table is increasing by 3. The 1 came from the fact that the 0 term was 1. After we write the equation, we'll want to pick a term number and prove that it works. Let's try our equation for term 2. This 2 corresponds to I want to know the number of the second term in the sequence. I simply replace the n with 2 in our equation. So since I'm looking for term 2, n is 2, so in my equation, this n becomes 2. Now I solve this equation. 3 times 2 is 6. 6 plus 1 is 7. So according to my equation, the second term should be 7. I go up to my table, and I'll notice that the second term is 7. So I am correct. Let's try another example. First, look at the sequence and determine what is the change. It appears the change is adding 5. If you can't tell that it's adding 5 just by looking, what you could do is take this term and subtract this one. So 16 minus 11 is 5. You could also take this term minus this one. 11 minus 6 is also 5. So this sequence is increasing by 5. Now I will find the next term in the sequence by adding 5 to 16, giving me 21. And to find the 0 term, I will actually subtract 5 to get the term before the first one. So 6 minus 5 is 1. Again, you can follow the pattern of the sequence. It should be increasing by 5 every time. Now I will write the equation for the sequence. We always start with t sub n. The next thing I do is the change. The change is plus 5. Multiply it by n. And then I include the 0 term, which is plus 1. So the 5 came from the change in the table. The 1 comes from the 0 term. After you write the equation, you should pick a term number and prove that it works. I'm going to test term 3 this time. So I replace the n in the equation with 3 and then solve this equation. 5 times 3 is 15. 15 plus 1 is 16. Now I should move to my table and make sure that the third term is 16. The third term is 16. Let's do another example. Here, the sequence is increasing by 4. So to find the next term in the sequence after 16, I simply add 4. To find the 0 term in the sequence, remember I subtract 4. 8 minus 4 will give me 4. Now I'm ready to write the equation. Again, we always start with t of n equals the change, which is 4, times n, and then plus the 0 term, which in this case is also 4. So this plus 4 gave me this number, this 4 gave me this one. I will now pick a term and prove that it works. This time I'm going to choose term 2. It doesn't matter which term you pick, but pick one in the table so that we know what the answer is. So I replace n in the equation with the 2. Multiply 4 times 2 is 8. 8 plus 4 is 12. The second term should be 12. Moving up to the table, the second term is 12. The last example. Here's my sequence. It appears to be moving up by 6. My third term was 7, so I add 6 to get the fourth term. I need to move backwards from -5 to get the 0 term. So I take -5 and go back 6 more. That's -11. I'm now ready to write my equation. It always starts with t of n equals, the change was 6, and the 0 term was -11. Now I'm ready to prove that it works. This time I'm going to pick term 4. So I would do 6 times 4 minus 1. I'm sorry, minus 11. 6 times 4 is 24. 24 minus 11 is 13. Checking that in the table, the fourth term should be 13. The fourth term is 13.